Yeah, I'm in my full Fancy Pants attire and with also the new Mr. Fancy Pants t-shirt from my new store on 4th Wall. I'm going to ditch Spring, which annoys me, and the quality gets worse, more and more expensive. Anyhow, the reason I am attired so beautifully is because I finally want to try the disc on the HP 9825. Hello and welcome back. If you follow the channel, you know that we have had a long battle with 8-inch floppy disk drives. These are not the itsy bitsy 5 1/4 floppies, no. They are the real deal, the original giant 8-inch floppy introduced by IBM in 1973. My giant floppies belong to my HP 9895A dual drive units, which I brought back as part of my big Los Angeles haul of 2019. There was only one problem with the units I got. All of them had found their way into the pile of shame because they were faulty. The drive mechanisms proper are not from HP, by the way. They were made by Magnetic Peripherals, by then a division of CDC. We spent the previous episodes repairing them, changing the broken brakes, the broken belts, the crusty bearings, whatever electronic faults they had, and realigning them. In the end, we managed to repair all of the drives except one which had a burnt head. One of the drives is already installed in Usagi Electric's Centurion computer, so it's about time I put the remaining drive into my own enclosure so I can use them with my HP computers. But the HP 9895A is much more than two floppies in an enclosure. The 9895 includes a large proprietary controller card that communicates to the computer via a high-speed HPIB bus. The card implements a high-level interface known as the Amigo protocol. It was very much ahead of its time, and you can think of it as a precursor to SCSI. Because of that, it can connect to all kinds of vintage HP machines, my HP 9825, the HP 85, the HP 9845, the HP 1000 computers, and anything that speaks HPIB natively, which is most HP early computers. This is why I'm so eager to get them working again. Go. Yeah, with elegance and distinction. Now I have to remember how the drives go in there. So we have spotted a big refa that's already... It's cracked, right? Yes, it is cracked. Okay, it's a new refa is in, but David is going to make the old refa thing. What?
Don't you lay the blame for this on me. This was your idea. Here we go.
I think that whole refa thing is overblown.
Heyo, overblown.
It's pretty cracked, so I'm surprised it didn't go up in smoke, but I guess not. Oh dang, we screwed up our electro boom moment. Okay, so much for our failed refa blowing experiment. Let's bring up the linear power supply on the Variac. We had already checked that the caps were good, so the supply behaved perfectly as expected.
Oh, we're starting to get a little bit of fan action. See that? Our AC fan is coming to life. So that's about 60 volts. Just send it.
Yeah.
There's 120.
Yeah, 12 volts. That's what it should be.
12 volts DC. That's exactly what we were expecting. I see zero ripple.
Yeah, nothing.
Those spray caps are brilliant.
Oh. What's the tagline with Sprague? They had a funny tagline.
They did.
It's don't be vague, insist on Sprague.
I forgot what it was.
But we were too old, we can't remember. We need to replug the board and then we plug the discs in and then we try it.
Yeah.
By the way, this is a beautiful board and the big white chip is the HPIB chip, the Phi chip. And there should be a Z80, I suppose it's over there. The oxide gold. Yeah, they are pretty dry. There you go. Before inserting the drives, you need to jumper them to the correct address, which can be anything from 0 to 3. The usual config is disk 0 on the left and 1 on the right. Okay, so make one DS0. Oh, this one is a different kind of switch.
That's the
I like this one better.
That's the ones that CDC uses on all the hot drives.
Okay, so this is
That's your AC.
AC. We are keyed. go. There you go. It should be able to go through its spaces, right? Yeah. There are some LEDs down there. Do you see them?
Oh yes, they're tiny. My God, they're small. Okay.
So the idea is that it self-checks if we end up with one LED on the right, we are golden. If it gets stuck somewhere, we'll have a code that we didn't have to decode.
Are you ready to go full send?
Okay, yeah, I think that's all we do. Go poof. It's blinking. It's blinking. Oh, there you go. Passed.
Yeah!
All right. This means it passed initialization. We need to format a disk, and then we can do one more test where it actually reads and writes on the disk. So the next test where we'd actually read from the disk called for a formatted disk. I was hoping to create one from the PC using Dave Dunfield's great image disk program. So I fed a utility with the right incantation to create an IMD image with the correct HP sector information. Then I wrote the image onto the disk. The formatting info checked good while reading it back on the PC. However, it would fail the read test in the HP 9895. Okay, for the next test, apparently, which is a long read test, you have to press and hold this, which will be a challenge because it's at an awkward place. Looks like an unhappy puppy to me. Same result. 3 LEDs and a blank then LED. Okay, I'm not sure what that means. That meant it failed the read test. With a bit of further research, I finally realized that you can't write nor read an HP 9895 compatible disk from a PC. That's because at the very lowest level, the magnetic bit encoding cell, HP is using a non-standard method. They did not use the prevalent MFM encoding, which stands for Modified FM Encoding, which doubled the bit density over the original IBM FM encoding at the cost of a more complex decoding. HP wanted to improve it even more to gain a few extra % density at the cost of an even more complicated decoding. So they ended up with their own scheme, which they called MMFM, and that stands for Modified FM, which can't be encoded nor decoded by a floppy controller on a PC, no matter what software you use. Only our overcomplicated HP controller board can deal with MMFM. Bummer. Fortunately, although the documentation says to use a formatted disk, the right test mode will actually lay down full new sectors before performing a verification read. In a sense, it is reformatting the disk track by track as it progresses. So that should work on an unformatted disk, contrary to what the doc says. There is just one more lever to push. Let's try that. Okay, so for the test, I think we actually can use unformatted disks. We put one here, put another one there, and then we go down to look at the test LEDs, and there are 2 switches, and we push the left one and the right one. And I think that will do a read-write test. And I can see the heads advancing one track at a time. And there's the 2 tests. There's step, read, write. Step, read, write. For the 2 disks. And I think that will format the disk. I just have to hold those 2 buttons for a long time. Yes, that seems to be working, and if my thinking is correct, the disk will be properly formatted after this test. So if I repeat the previous failed read test just with one button, now it should work. So now if I press just the right side, I should be able to do a read test. It should go faster. Yeah, it's doing it. Success again! Our disk has now been formatted in modified FM, and everything is behaving properly. Well, I think we have repaired our disk drive. So I think we can write, we can read. I think we're ready to connect this to a computer. And to hook up the disk to the 9825, you of course need HPIB. It goes from here to the HPIB interface in the 9825. And also you need a ROM because the disk is not supported by the machine with the factory ROM. You need to have one of two ROMs. The original HP ROM, which is super hard to get, 98228A, or as I have here, that's called the SSS ROM. The SSS ROM is a third-party ROM that also works with more modern HP disk drives. It also used to be as rare as hen's teeth, but thanks to HP enthusiasts Jack Rubin, Paul Berger and Adrian Nichols, a replica is now available, and that's what I have here. Okay, I've got the lazy T, and this is going to get loud. Alright, so I need to do drive 0706. So that's the current address is on 706 in GPIB, and this is the left base 0. Execute. Okay, and now I should be able to do a D type, and it should recognize the disk. It gives me 1, which means there is no disk in there. We are gonna try to format a disk, and I just tried it, and actually I thought it wasn't working, but it does. It just takes absolutely forever. So the magical incantation is in it, and you have to give it the full address of the drive. Alright, go. And at first I thought there was something wrong because it went on forever. Actually, it's perfectly fine, it just takes forever. So this is a very slow system, I didn't expect that.
A little longer than a few minutes later.
Oh, and go. Alright, so 9 minutes and 14 seconds, which is why at first I didn't have the patience. I thought something was wrong, but no, it should work fine now. So we do cat. It just told me what's on the disk, which is nothing. So the easiest way to test it will be to put another disk in there, which should have some programs on it. So if I do drive 1706 this time, and do a cat, whoops, hello. Right, it has the prime program on it, so we'll do get primed, and it should read it from the default disk. It did, so now I'll save it. Drive 0706, save, test. Alright. Alright, so now I do cat, and I should have a file on there. I do test. So now if I do erase, I should have absolutely nothing in there. List, lists nothing. Get, test. Try that. Done. Should have it in memory. And I do run, and it's going to compute the prime numbers up to 5,000. So at first it's slow, but it gets faster. There you go, it's getting cranking. Okay, prime numbers up to 5,000. Yoo-hoo! Usagi Electric will be jumping all over because this took us so long to get there. Excellent! We now have a disk system for the HP9825 calculator, avoiding the finicky tapes, and with a capacity of about 1.2 megabytes per disk, which is just plain gigantic for the 64 kilobyte memory machine. However, we'd also like to use it to exchange files with a PC, and that's not as easy as I thought because of the MFM versus MMFM encoding snafu. So the problem is how to recreate a new old disk from the PC so we can then read them in the 9825. And as we have seen, because of the MMFM modulation, we cannot use the drive directly, but we can use the controller to deal with the MMFM and connect that to the computer. That's exactly the system I have here. It has an HPIB card, and the HPIB is connected to the back of the HP9895 disks, so it talks to the controller, and that's gonna work. Assuming we have the proper software, which I do. And the software in question is called HPDIR. It's made by Ansgar Kukas over in Germany, and I have it running right here. So what I'm gonna do is shove my diskette into the disk drive, and I'm going to do hpdir/query, and it's going to find what's on the HPIB bus, and it tells me HPIB 9895 at address 0, which is the address I've set this one on. So I should be able to do hpdir-format, and then the addressing is a little bit bizarre. It's 700, the address of this one, plus 0 for the left drive, and the semicolon. Let's see if that works. Are you sure you want to proceed? Yes. Insert drive, yes. And it's doing it. Okay, so that worked so far, so it should be correctly MMFM formatted. And then I think I can just duplicate the image. So this has been recovered quite recently from some HP's Engineer collection. It's Adventure, so the Colossal Cave Adventure game. And I think that's the name of the file. Let's see if that works, because that should recreate all the directory, everything. It's a binary image. Can't open file. I found what the problem was, is that HPDIR can't read yet the smaller one-sided archives. So I had to pad it and make it look like a bigger file. Adventure 9895.hpi, and that it can open. So we are going to do hpdir-dup with my padded file, and it's just going to truncate it, but it's just added 0, so it's going to be fine, hopefully. There we go. That works. So chugging along down there. And we got the magic line. Okay, so that should have worked. I'll let Ansgar know about the quirk that his programs doesn't open the smaller disk archives and probably fix it. So let's now see if we can just read what's on the disk and the files that are in it. Yeah, it got all the files. So hey, we should have gotten our new adventure game on a disk, which was a copy of the original that was recovered by that from that HP Engineers collection. Okay, we should have all we need: the adventure game diskette, the cheat sheet with the map of the cave, and here I have both the diskette reader connected via HPIB and my trusty Juki serial printer. First, I want to make sure it can read the file. And it looks like it got them all. This is why you need the diskette. You could not do it from the tape. Now we're going to start it by doing get advent, and it's case sensitive. And looks like it got it. Run. It's asking if I want to start a new game, and I say yes. And I have to press continue, not execute. So by default it prints on this, but we want to print on the bigger printer. So the printer is on the serial interface 10, and it's 80 columns. And it came to life. What did it tell us? It told us, welcome to adventure, would you like instructions? Yes. And it says, somewhere nearby is Colossal Cave, where others have found fortunes in treasure and gold. So it is rumored that some who enter the cave never come back. Tells us where this was done at HP in Fort Collins, where the 9825 was developed by Eric Nelson and Craig Robinson. Thank you very much. So that's an adaptation of the original PDP-10 game. And it says, you are standing at the end of a road before a small brick building. Around you is a forest. A small stream flows out of the building and down to a gully. So we are going to enter. And it tells us we're inside the building, so there's no screen, but it doesn't matter because they tell you with text and you make the picture in your head all in color. So you got it. It's way more than a text game. It's an illustrated high-resolution color game. It gives you wonderful prompts so you can create your own pictures using your own imagination. No artificial intelligence needed. What a concept. So there is a lamp and food and keys. So we're going to get the keys. So we're going to need them. And we are going to get the lamp. Okay, and then we're going to exit the building. No. because I typed enter instead of continue. And then we look at our precious plan, and we are going to go there, down to the grate, open the grate, and enter the cave. South. You are in a valley in the forest beside a stream, tumbling along a rocky bed. And you can make the picture in your mind. It's going to be high res and in color. You go south again. At your feet, all the water of the stream splashes into a 2-inch slit in the rock. Downstream, the stream bed is bare rock. And I think we go south again until we hit the grate. Okay, there is a steel grate. Open grate, and since we have the keys, that will work. And it's reading from the disk. I can't see it over there. It's taking a little while. And we're going to go down. So we're going to go west. Crawling over cobbles in a low passage, and there's a small wicker cage. So we get the cage. Okay, and according to my map, we have to go further west. It's now pitch dark. Lamp on. Your lamp is now on. Note on the wall says magic word is ZZ. Z. And that did transport us back into the building where we were at the start.
Moments later.
And you got the bird. And so on and so forth. The bird will help you to fight the snake and all kind of things. But I think that was totally worth it. Well, I think repairing our disk drive was worth the effort. We transformed our calculator into a nice retro battle station. But we are not done. We have more drives to repair, and they won't be as easy as this one. They will force us to break out the logic analyzer to troubleshoot the misbehaving and mysterious HP controller board. But that will be for another episode. See you then! So that's the refile we pulled out of the HP. If you look at it superficially, it's still a good cap. 0.5. Let's test it for leakage. 25 volt leak test. It opens up a little bit lazily, but if we go 150 volts, yeah, it's leaky, so eventually it would go boom. So maybe we didn't give it enough beans. Oh, it's a tough refill. 450 volts, and it has a few milliamps in it. It's sitting at a good 500 volts. I read it wrong. It's only 0.4 milliamp DC, so that's not enough to heat it up. And it's not even going up a bit, so it will not fail today.